Okay, before the break, we were looking at some object-oriented stuff, class notation, a really quick pass at it. That's just the beginning, right? Where we can't. There's not enough time in a classroom to talk about every single thing there is about Python. So we try to do that base pass. Y'all can look up stuff for your particular things. That's why I leave lots of time at the end of class when I will just be sitting there waiting for questions to come my way. Because we did the quick pass, but maybe you have something very specific that you know you're going to need in your stuff, and we can address that as an individual question. Still stuff to look up, but you all know how to do that. Look at things. We were talking about classes and trying to fit a lot of stuff in very quickly because we're going to use it as a data class by the end of the night. But we can so we've made some child classes that have more details and created those, but we can create an animal class. There's nothing stopping us from that one we made before the break, right? It would work perfectly well. But sometimes, let me go and share my screen because I was getting ready to point at something. This one, we could have just used the method and bypassed this parameter here. We don't really need that. The only place it's going to show up is in that make sound method. So we could just do that and then keep overriding that method. But maybe we wouldn't need one for the overall animal. For that, the example of a veterinary clinic, they know what animals they're going to bring in. Or they're going to make a new one if they get some random animal they haven't had before. They're never going to do the generic animal object. It's only there so other stuff can inherit from it. In which case we wouldn't need to make that method, but we know we would use it. So the example I'm going to use, I'm going to go back over to Spider for this. Go back to a regular Python file and use different ones. So no, we don't update. Is a shape. So geometry stuff. Basic shapes, squares, circles, rectangles. We know certain things.
Geometry.
Geometry, yes. Like from your math class, right? We know certain things about the shapes we would look at. For example, one of them, ours is going to be a very stripped down quick example, so we can get into the data stuff here shortly. But we know everything is going to have an area. And probably you've had by this point in your education, you've had it drilled into your head the area of a square and the area of a circle, area of a rectangle, a few of those formulas. Maybe not every single one, or maybe not some of the super complicated shapes, but you know some of the formulas. So if we start inheriting things, when we make that, we know everything's going to have a get area method. But we won't know what that area, the calculation is until we get to a specific shape, not the overall shape that all of our squares and circles and triangle classes are going to inherit from. That's where abstraction comes in. So I got some notes for the board here. So in many of our object-oriented programming languages, we have a special type of object known as an interface. So abstractions and interfaces, it's very similar. And what we want from an abstract class is the same thing we want from an interface. I'm going to talk about that for a moment. So interface. That's not an I. Interface, and the actual definition of it. If you go check the dictionary, there's noun and verb one. I'm just starting with the noun one here. A point where two systems meet and interact.
I guess that makes sense because I was like, why do I keep thinking GUI? Why do I keep thinking GUI?
Systems, yes, that's an example. Systems meet and interact. GUI, a GUI would be for the graphical user interface. That's where the computer system meets and interacts with the human system. Or I guess it would make more sense to say that sentence the other direction. The human system meets and interacts with the computer system. On the side of my laptop, it's a USB interface. So this physical hardware meets and interacts with another thing through this interface. There's some set points, those connection points, those standards are the same on anything. And I just said we're going to do a shape class. So we have that thing that all of our other shapes are going to inherit from. Side length. It's got some data field, side length, or we're going to do a quick version, but the things that they're all going to have in common, and then we'll make the particular shapes, the triangles and squares and stuff later. So we can set up some classes that act as an interface. In some of our other languages, we have what we're going to see is the abstract part of the class, but it gives us a way that we would know to work with. And polymorphism comes in. The squares, rectangles, triangles, all those subclasses are going to be polymorphic to the class itself, the class shape itself. So when we set up things earlier, and we check that is instance method to make sure we have the right data type, we can check to make sure it's a shape. And then any subclasses of shape would work, whether it's a hexagon or an ellipse or a trapezoid. There's lots and lots of shapes, but when we might not know the full list of what we're going to have when we originally set up other methods that need to use that. But we know there's going to be a get area method. So we can put that in the parent class as an abstract and then define it later, which means we won't ever be able to create an instance of that shape class because not everything's defined there. It's like the USB port. We set up the design for the plug, but we can't actually do anything with it until we have the USB cord that plugs into it, right? Or the little USB dongle that plugs into it. We set up the shape, we create and prepare the interface, both sides of that interface, but it's not going to do any good until later when we have the pieces to actually plug in. So
Chris, what does that last word say? Systems meet and what?
Interact.
Okay. And if you had a USB plugged into it, it still has it has to be connected. The other end has to be connected somewhere else.
Yes.
Okay.
Yeah, because then we just move. If we just have the cable, it just moves the interface a little bit.
Not
further.
interacting with anything. Okay.
Yes, both parts of it are important. As a verb, from the dictionary, means to interact with another system, but that fits right with the noun. As far as making objects, it makes more sense to look at the noun. So the first example on my notes is the one you pointed out, Tiff. A graphical user interface is where a human system, brain and hand oriented interfaces with an application level software system, object oriented. So we have that interface that connects the two things together. The plugs are set up, right? All these computers in this lab here have VGA cables. They did not make that entire system at once. One factory made all these monitors, a different factory made all those towers, and both of them come equipped with VGA plugs so that the tower could connect to all the monitors here in the lab. Let's see what else I have here. USB type A interface or an external computer system, such as flash storage interfaces with an operating system. The obvious ones, because we already talked about them before I looked at what I wrote down in my notes. The interfaces in software are typically introduced with called a list of rules. So I already told you what we're getting ready to write for our example, a shape method. So we're going to set up a rule that anything that wants to be a shape has to have a get area method. And we'll put that in the parent class, but we don't have to define it. We don't know what equation it is. We don't have a generic shape area. We have a square area and a circle area and a triangle area and a trapezoid area. And math teachers over the years have probably forced you to memorize a whole bunch of them, right? And I'm sure you're aware there's even more that you haven't seen. And that's just when we're in Euclidean math, because then it changes and we'll start bending things, right? That's the flat surface. The area of a circle changes if we start changing our the area where we drew the circle. But that becomes a rule. In order to be of the type shape, it has to finish that out. It has to actually plug in the interface, connect to that interface. And then when we needed to use that elsewhere, we don't have to wait for those child classes that are going to actually define that method by putting things, right? By putting return width times length for a square, or return radius squared times pi, pi times radius squared for a circle area. Right? We don't have to wait on those. We can go ahead and start writing the other methods that are going to accept that. So hopefully you can quickly see a usefulness on a team project, right? You're in a big team, hundreds of programmers. Somebody high up on the project management side can set up the interfaces. So then all the programmers know from day one when they start coding what other programmers are going to write. Like, okay, I know those people 6 floors away in this big skyscraper are going to write a get area method, so I can go ahead and use that and write the code I need to write. Where they would be used most often. Obviously, usefulness is when other programmers. Oh, yeah, I'm jumping right ahead. In C family, it's an object we can actually cast things into an interface type as a way to check that. We don't have that in Java. It also helps to offer a layer of protection against bad interaction between software. Okay. When we did that equals method before the break, we used the weight. But what if we tried to pass in an integer? An integer doesn't have a dot weight. That would cause a big error. So an interface is like rules that protect us against that. You think of it, the USB plug. I got the one in front of me with my little pen. There's a USB A on one side, and what is this? A little Calypso Mini on the other side. So USB A to USB Mini. I can't plug the USB Mini into my computer. There's that layer of protection. Only the USB A side goes into the computer, and the USB Mini side goes into the pad that orients the pin. The pad that tracks the position of the pin.
So in essence, I mean, there's interfaces within the code itself, because if you have a variable type string, that no?
Yes, exactly. But the key word from what you said is in essence. We want to do that explicitly.
Okay. Because if they don't match, if the types don't match, it's gonna, the interface, basically the code's gonna say that, well, the console is gonna say error. You can't convert whatever it is. I'm sorry, you can't convert a string, or can't concatenate a string in a integer or something like that.
We can handle that. From what you said, it's like that, but we want to make it explicit so it is that.
Okay.
There's our interface is explicit, so with our object, I already said it's the shape, and we know all shapes have an area, so make a get area, and if anything that, then we have a rule, then we have the shape of that interface, how it plugs into other software because of that get area method, even though we haven't wrote any of them yet. So to do that, and to do that here, we'll need to import this ABC method, import ABC. And our class inherits from that in order to be abstract. That stands for abstract base class. Abstract base class. abstract classes and interfaces are very, very similar in some of our other languages. We don't actually have the interface type in Python, but we do still have abstract classes, so it behaves like an interface. So we'll make this class, call it shape, and it needs to inherit from ABC. And we have to do that in a special way. We'll say meta class is ABC dot, is on the predicted list. Nope, it's not. ABC meta with that capitalization. So the module is all lowercase. So the ABC module lowercase, the ABC capital meta. Yeah, the case is odd, but it does make sense why it's that way. Our modules are always written in lowercase, but it's an acronym, so it should be written in capital letters. And then the next word starts with an uppercase letter. So the names all make sense. And then we'd set up stuff like normal, define underscore init, underscore. We have to pass in the self parameter. And this is what you all were asking about the break. At least two of y'all said you were going to do this. Okay. We're not taking anything in. We have to have a constructor. So we have to have that method. There's ways around it, but yeah, from before long, we'll be slipping away from the ways around it, and we won't be able to use those built-in protections in the Python interpreter to automatically put an init method. Actually, more of that this week. Django's on the server is basically a customized common gateway interface. So it doesn't have a Python interpreter as a gateway interface, which means it's not going to automatically insert a constructor for us like the Python interpreter itself will. We don't have anything to do though. So we do need to put in that keyword pass. We've seen that before, right? Don't do anything. There has to be an indented line from Python syntax. So we have this keyword pass, which oftentimes when I'm writing code, I'll write all like the function names that I know I'm going to need. And I'll come back and fill them in later. So on the first pass, it has pass everywhere. So I'm going to do that part later. But first off, I want to think about all the names of the functions I need and go list those out and then come back and I'll fill them in later. But something has to be there. And that just means don't do anything. You can also just type return, but return does do something. Return sends back none, which is a type of data. It's not emptiness. Right? The computer's not shut off. The computer hasn't been shut off for hours, so all the capacitors and other electronic components have drained of electricity. There is still electricity flowing through there, so it's not nothingness. It is a data type. And now for our method. So we do this annotation. So at abc abstract method. And we'll define get area. Takes in a self one. And well, we don't know what to do here. If we're making a circle, we know what to do. Pi r squared. If we're doing a rectangle, length times width. If we're doing a square, it's side times side squared. But we don't know which one we're going to need. We just know that we will have that method. So that's our interface. That's the shape that we can, where two systems can meet and interact. We can go ahead and use that at this point, even though we don't have what we need to define it. And we'll say return just because we got to have something there. And eventually we're going to do a return method. I guess I'll do equals. Oh, that's a good place to use it. I'll go ahead and use it right now. Because when would two shapes be equal? When they have the same area, right? So we have a self and other. And we can set up that. So if self.get area is equal to other.get area, then return true. Oh, that's not true. Return true with a capital T. So we're in Python, not C family. Else return false. And I would never actually write that code that way. I did that for the sake of the example. Because self.area equal to other.get area is that itself is true or false, right? So normally I would write return self.area equal other get.area. And that automatically sends us back the same thing as the selection structure. Bless you. But for the sake of the example, I wrote it out this way. And some people do like to do that, right? Typing's easy. Don't be lazy with your typing. It more explicitly shows what it's doing so that if you have to look back at that code 6 years in the future to find a bug that you didn't know was there the first time you wrote it. When you do those separate lines, it's a lot more explicit what's going on. You don't have to try to think about what you were doing 6 years earlier when you wrote the code the first time. And I'm just going to add some white space because I don't like typing at the bottom. So we don't know what area is, but we can go ahead and use it. That's the idea behind interfaces and abstract classes. But we can't ask for this class now. We can't say S is a shape and then get anything to happen. We have to make, that's an abstract class. We need a concrete class to make stuff happen. Abstract class. We also need concrete classes, such as class rectangle. What are rectangles going to have? Rectangles. Oops, I'm going to make that a capital R. That's just the naming convention I like. Rectangles are going to inherit from shape. So we get all of that stuff. And when we set up our constructor, and the first parameter is always obvious, where we don't get an option on the first parameter. But then for a rectangle, there's going to be a length and a width, right? And there's places where rectangles would show up, would probably have color and filled and all sorts of other things about it. But for our example, let's just go with length and width so we can finish that out. So we can say self.length equals length h, and self.width equals width. That way we can refer to it everywhere. Let me come down here and go ahead and try to instantiate that. If name is equal to main, and this is where the guard statement comes in really useful, because we need a test case. The most logical place for a test case when we're writing the code is right here in this file.
You said the what kind of statement, Chris? You said this is where the what? The do-while?
Guard. This.
Okay.
If name equals name. It's called the guard statement. Whenever the file we hit run on gets renamed as __main__.py. Everything else keeps the file name we gave it. But the file name where we actually hit the run button gets a new name. And it's main, so we're going to check and see if this is the one we actually hit the run button on. And if so, then we'll do our test case. Because if it didn't get renamed main, that means we probably imported this into something else. In another file, we said import. I haven't given this a name, have I? Let me give it a name so I can finish that sentence. documents, delete. Oh, I have no idea where I saved that one. I have no idea where I saved that one earlier. So I called it shapes. So in another Python script, we're going to say import shapes, and then we can use this. And anything that's just written in here would automatically run when we did that. But we probably don't want that to happen. So this just guards against that automatic running code. So if I try to make a new one here, let's say R is a rectangle. And we need two numbers, so 3 times 4. Print R. Oh, I'll do that in the representation as well. Define underscore representation, or string if you just want to use string. I usually use string, but I remembered representation is there earlier today, and it's generally considered better form. We can return as a string the results of that self.getArea method. So we already used that interface, so we know that's going to show up. So now rectangle is going to inherit that. So whenever we say print, it's just going to automatically call the area. I haven't put that in there yet to show what the error message looks like. So if I run this, get zoom buttons out. So we can't instantiate an abstract class. We haven't followed the rules. We didn't, right? We set up an abstract method, which is how we create interfacing. We haven't followed the rules for interfacing, so we can't plug the things together. Right? What was our rule to be a shape?
It has to have an area.
Yeah, it has to have the get area method. So methods is how we use it. The behaviors, the outer circle on that donut picture I drew earlier. The behaviors are how we connect them together, because it doesn't have a physical shape like the USB. More like a GUI. Click here. That's an action. That's a method. So it's kind of like that. We set up our methods, and that's how we interface things together. So usually starting off, we use that terminology. It's a rule we have to follow. We didn't follow the rule, so we got the error message that says we can't instantiate that. Didn't follow the rules. So we'll go ahead and put that up, because now that we know for certain, I put self in here, didn't I? Yeah. Now that we know for certain it's a rectangle, do we know how to find the area? Can we do the equation now? Somebody want to tell me what the calculation is for a rectangle?
Isn't it length times width?
Yes. Now we can do that math. We can define what get area means because we know the equation that defines the area of a circle. Oh, whoops.
Circle?
Sorry, a rectangle.
Self. Okay.
The circle is the next one.
So,
Now we do another. Circle was already on my mind. Make
so
sure
we
you do.
need to do self.length times
Yes.
self.width. Okay.
That's why our parent constructor didn't have to do anything, because we're going to do that later. Because on a circle it'd be very different, right? Oh, well, let me hit run to show we don't get that message anymore. See, now it works. The area is 12. So we know the representation. I guess I can put that in here. Return the area is plus that. We can make another rectangle. So there's RPQRS is another rectangle that is 2 by 6. T is a rectangle that is 3 by 3. So actually a square. But we can do little comparisons now, right? If R is equal to S, print those are the same. Otherwise, print don't match. So we can do that comparison with that equals, right? We saw that earlier. But the difference is that when we define the equal, we didn't know what get area was going to be. We had to define that later, but we know it's there now, so we can use that. Those
Why
are
do
the
we
same.
only care if R is equal to S though?
In this case, this is just a random example.
Oh, okay.
If you were doing math homework, you might care if two rectangles were equal,
Mhm.
right? Because that's the question your math teacher might ask you. Or if you were doing some engineering, are those equal? Or it's equal size, or there's reasons why we would care. For our case, we just care about the syntax. A rectangle is a simple example to start with. Does that abstraction make sense? And we can do that with all of our shapes. I'll just do one more real quick. Define circle, which again inherits from shape. Define image.
And in it, is that initiate?
Initialize.
Initialize, okay.
I actually like to think of it as in it, because it's listing
Like
out
inside of it, is that what you, when you say in it, like inside of this clock?
what is in this object.
Okay,
I think that sentence, that didn't even make sense, but it stands for initialize. The generic term is constructor. It's the constructor for our object. That's the one that the general category of where it falls in that we have in every language. We have ways to set up constructors. We only do one constructor in Python. If you've done C family stuff and got used to overloading constructors, we can only do one constructor for our object. What do we need to make a circle object? To make some circle data.
like you said, pi, the circumference.
So pi's a constant. That's always the same, right? The other one, yes,
Radius.
a radius. So then again, self dot radius, so that we can ask for it from our instance.
You get the circumference from the radius, right?
Circumference is two times radius.
Okay.
Oh wait, no. Circumference is the way around. Diameter is 2 times the radius. Circumference is pi times diameter.
Ah,
Circumference is 2 times pi times radius. So we can build it all from the radius. That is the definition of a circle. All points equidistant from a single point. Right? When you draw a circle, you put a nail in a board and then tie a string to it and put a pencil at the end of that string and move it around. Everything that pencil touches is the same distance from that nail in the center. The radius away from it. That's how we define. That's how a circle is defined.
Keep that circle be a class instead of a function. Or method, I'm sorry. You have a method instead of a class. Right?
Oh, yes. Thank you. It should be should be an object. Design an object. Then we can do the get area. So, and we know what that is. It's we're going to return self dot radius pi r squared. So radius squared. Since it's an integer, the caret would work for the exponent, but the caret is the XOR operation, and it's just a coincidence that it does that for binary integers. It does not work if we put fractional integers there. So for exponents, you want to use 2 asterisks, 2 stars. I'm a math person. In math, we call that star because that's a lot easier to say. It's 2 stars, And then pi, there's different places we can get it. I always use the math library. So I'll come up here and import math, which goes nicely with shapes, and we already have all this built into shape, built into the math library anyway, so. And then we can say math dot, I think it's lowercase, yeah, math dot pi, which is 16 digits of pi. We used that last week, didn't we? When we turned it into a string and used that for our generators, I think. Oh,
You got it to show up in the console.
yeah. So pi is a constant. We don't have to ask the user what pi is. Actually, the user couldn't really tell us what pi is. Somebody already spent a lot of time in that using doing Monte Carlo simulation, get a very, very accurate version of it. And then we can set those up. C is a circle. And all we need is one number, 4. And then when we say print C and save that, we'll see that the area of that circle. The main thing on that was, well, another quick pass of the class notation, object stuff and instance, and then the instances of it. So, does your question from earlier make sense now, Tiff? At the beginning of class, you asked about instances. Does the difference make sense now?
Oh,
So,
yeah.
where we design a rectangle. But then down here, R is an instance of that design. So R is an instance of it, or S or T, one of the letters I can pronounce correctly.
Why did you put where did the 4 come from? Sorry, in the circle.
Oh, I just made out those numbers, length and width.
Okay, so R is radius. Okay, I'm sorry. Hey, I'm good.
I just,
Right? Was R radius?
yes. Because we can make
Okay.
a new circle with every single number.
Okay.
Right. Let's do that real quick. Because I think we're going to get behind schedule from what I was wanting to do. We'll start looking at data.
I'm
but-
sorry, y'all.
Oh, it's all right. There was a lot crammed into that online statewide shell I was trying to use. I'm trying to align that, so I'm having to adjust the lectures that I've done previously in this class. Because this is what we want to make sure this makes sense. And the API, I wanted to do APIs, but I wanted to cover data storage before we get to APIs. But that's only going to take about 15 minutes to show the base case. I know those videos I send are an hour long, but it's only going to take us a few minutes. But hopefully we'll get there. But we can do lots of circles now. We can create lots of instances, right? For C in range of 12. Make that I. For I in range of 12, C is a circle of radius I. And then we'll print those out so that we see how much those numbers increase. Radius 0 is a point, so obviously it has an area of 0. Then radius 1 squared is still 1, so our area is pi. When we get to 2, it jumps up quickly. 0, 3, 12, then from 12 to 28, it's growing exponentially, right? If we were to put that in a plot and put that up, I don't think I have the plotting installed or any plotting libraries installed. We'll see that soon. We would see a particular curve growing exponentially quick. But we can see how area increases as we increase the radius, something like that. And then we can create lots and lots of them and use the same data design in different situations. The idea of abstract classes and interfaces makes sense. In other languages, we actually have special objects called interfaces that are nothing but abstract methods. They are purely abstract. We don't have any data fields in them or anything. And we don't necessarily make children of them, they behave different. But the same thing applies as the conceptually abstract objects. That's how we create an interface or how we interface, that's where it's both a noun and a verb. It's how we interface our objects together and how we work with them, how we build them up. Hopefully that makes sense. Any questions about that? This code will be on GitHub shortly after class. I'm probably just going to use the web interface tonight, so that won't be in the recording, but within a few minutes after the lecture ends, the class examples will be on GitHub. So I'm going to go to another one now. So clear all this out. Whoops. Control L clears in Spider. Just do that. So now the data class that we're going to need to look at storing data. Those who haven't had me in class before, I always use basically the same classroom example data to simplify things. Well, I do different ones, but my most common fallback is people data. So I'm going to make a class called people.
Yep, you always talk about Bob.
Yes. That's a good good fallback name. Actually, over the last couple of years, I've switched it, and now I do Sally from Salem, and Charlie from Charlestown, and Mary from Marysville. I use some local cities. Louis from Louisville, and just go through some very generic examples like that. But Bob's a good name to fall back
The
on.
only one I haven't heard was Louis from Louisville. All the other ones I've heard.
Oh, we did. Yeah, I stopped. Bob and Sally used to always be my fallbacks to go to, but then there was a Bob in a class. I didn't want to use his name in the class. I didn't want to use the name of somebody in the class. So Bob drifted out, and there's not a Bob Town or Bobville around here that use, so it didn't work back in. So a people data class. And this one would be like a data class, because we don't necessarily need methods. This is for our data. Because the thing we're getting into here is creating databases. The technical version of database. Right? The file structure on your computer is a database. Technically, it's a hierarchical database. You would never call it a hierarchical database. Even people that know that term would just look at you like you're weird. Like, why would you call it that? It's a directory structure, or maybe just say folders. But it is the technical definition of database is a place to store data on a computer. I will write that down on the board at some point soon. And then on Wednesday, when we get into APIs, that's what we're doing. Application programming interface. We're interfacing data to transfer between applications, between our application written in Python and another application written in we don't even know what language. So probably send JSON. I said earlier, both of those videos, they talk about JSON. One of them even says it's text. It's not text, it's JavaScript. It is a different programming language, but that's what's used most often. And they don't give a clear distinction of it. Or I didn't think they said it properly, because the difference of when we would use one over the other is what's going to process it on the other side. If you know you're going to a strictly typed language, you should use a markup language, because then we can transfer the type data as well. If you know you're going to an open type language like Python or JavaScript, then you should use JSON, because it's already in the format it needs to be on the other side. And most of the time it's Python or JavaScript on the other side. So that is why JSON is the most popular one. As far as going through the machine, if you're worried about efficiency, markup languages are much, much better than object-oriented languages. Markup languages are very, very good for the machine and decent for humans. They're decent for the machine, decent for humans. Object-oriented programming, object-oriented things are great for the human, horrible for the machine. So if you're worried about efficiency, you want to go with markup languages. That's why NASDAQ sends out XML, and we'll not be switching that to JSON, because those nanoseconds can mean millions of dollars for people with the way NASDAQ sends out every few seconds. So there are differences in when we would want to use one or the other. And normally we don't type it anyway. We type our class And then one of the methods is convert to JSON. Or one of the methods is convert to XML and adds the tags in automatically. So we don't type them anyway, except maybe the first time where we write the method that writes it, but those are also built into the language, so we don't have to write it the first time. We just say, turn this data into XML or turn this data into JSON, and then we send it. So people will define our constructor. I go with self, and then I just go with name, age, and town for our class example. That's a good version of people. Yeah, one of those videos uses sodas instead of name, age, and town. They have a flavor and a description. And your homework uses books, so you need the ID or ISBN, the author and publishing company. Maybe it was title and author, but just a couple of data fields, something small like this. So the first thing you probably want to do is define a data class. You're not going to need any methods. It's purely a data class, not a class. Class. It's still object-oriented programming, but all we're doing it for is data. So it really is like a row in a database, a record in a database.
So on that square with all the database, all those little squares, the one going across is going to be people. It's going to have name, age, like that whole row is the one instance for people for that right there.
So we just need
Okay.
to say a few things that we would need. Maybe we might want a couple methods, like when we're doing this because we're going to process that data. So we probably want, well, I'm going to do equals again, but there is a GT and LP, greater, less than. We have those in there as well, but they behave in the same way as equals. And then we would call them with that symbol in a condition structure. So we need self and other. We'll make people equal. Age. Sounds good. Makes a big deal for 21-year-olds, right? I know a lot of people in college are that age where some of your friends are 20 and some of your friends are 21, and you can't do the same thing, right? On the weekends. That's one of those age gaps, or a big deal at 18. Right? When you're 17, the government says you can't do anything, and then for some reason at exactly 12 midnight on a random day, you can suddenly do all sorts of stuff. So age is a good one for comparing people or saying people are equal. So if is instance, we didn't set up any interfacing, so there's no interfacing rules. So we'll have to use one of these. We'll just do that check to make sure we have the right type of data, which technically isn't an interface, right? Where I was using the USB plug as an example. I wouldn't try to plug in my power cord I wouldn't go plug up my power cord to decide whether or not that's a USB cord. They're made a specific way. So an interface is a little different than the methods that just check, but it is a good analogy. I think you asked that. Was that a question you asked him? Compared to this method earlier?
Yeah, why wasn't it plugged? Yeah, about the
Horrible human being.
interface, sorry, and the USB.
Similar, but it's like just throwing things at the computer to determine whether it's a USB port or not, right? It's like grab the marker and go, oh, the marker's not a USB port. So an interface is a little bit more graceful about it. But it leads to the same result. So if it is instance other, we don't have to check self. We know what self is, right? We know what class we're in. But if other is a people, then we can compare them and return self.age is equal to other.age. That's the way I would usually write that line, because that returns true or false, and then we don't have to actually spell it out. But like the way we did it earlier, it's explicit. You look confused, Tim. If I put parentheses on there, well, maybe that'll help. So first thing we're gonna do, order operations parentheses first, we do that comparison.
Yeah, I was looking at the method there. Is that there's no, I noticed there's no camel case, no underscores. Is that always all lowercase put together?
Yes.
Okay, I'll have to be careful there.
It was written by a lot of different people who did what they want. It's not like Java or C# where we always all follow the same notation. It's like Python and C++. A lot of different people just did what they felt like doing, and the same people might feel like doing different things on different days. Right? One person wake up on Monday and write some code, and then on Thursday they wake up and write some other code, and they might not name their variables the same. So it's even in the same, like they were still working on the same module that other people are going to import and use, but they would write it different. But then so this is true or false. It's a really complicated way of writing true or false. So we'll just return that true or false, and we get our equality that way. Maybe a representation as well. Define REPR, self, and return. And this class we are going to be using for the rest of the week. Because we're going to look at storage, persistent data, files, maybe not sequential files, but those are the easy ones, right? We just create a file handler, right? Things that human readable text file, one variable per line, then read them back in the same order. I keep saying that because we're probably not going to cover that. We're going to do other types of file writing for storing data, and then we'll go to the API, application programming interface. That's something we do a lot with Python because other software might need our data. And it could be written in any other language. So we need to find ways to get it to transfer it to the other one. We'll see that. But this will basically make our database for this the rest of the week.
So we'll be able to set up APIs to configure passwords and stuff like that. So
We won't go that far.
okay. I know that we did that with our JSON, whichever class I was just in. I can't remember, but yeah, the JSON. Okay, good. I'm glad. I'm glad.
That was probably using an API to set up your password. We're going to make an API. We're making APIs.
Okay.
We're actually making APIs that other people use. Small examples here, but it's going to be something like this: an API that returns people across the internet, so that any software on any machine that can access the internet can ask for that from the web address. Is what we're going to be making. But I'll just finish out this string here. If self.name is self.age years old and lives in self.town. Period. So probably no surprises about the string representation there, but I'm going to make a new folder here because we're going to be working on this all week. I'm going to call this one
People.
I didn't want to call it people. I was trying to go more generic than that. Maybe data and API. Data storage and API. I'll just be explicit.
So what's another example then, other than people, that we're going to be working on this week?
Oh, we're going to be working on people all week.
Okay.
Y'all have noticed a lot of times I'll just sometimes even match the keyboard. I took a moment to give this a very, very clear, precise name. Hopefully that's an indication that this is going to be a big deal. I expect y'all to pull this one off GitHub. Much more than some of the other ones, right? If you're following along, you probably have your own versions, but this stuff you'll want to be coming back to all week. So we'll store people in here. So this is people.py. And then we can create instances of it. which I'm not gonna do here. Because it's a class, I'm always gonna import. The new one, first thing to do is import people, which might not be in the same place. I'm gonna store it in the same place. What will this be? This will be simple storage. .py. So it's stored in the same place. Let's say import sys and sys.path. Notice we get this list. This is where it's going to look for modules. So the very first place it looks is several folders where that's installed. And tries to see if there's people.py there. Then there's a blank one. So like relative addressing, it's going to concatenate /people.py on the end and look and see if it's in the same folder. And then it's going to look at some other places. But if it's somewhere else, we could include it. So that's just a list. So we could say import sys and sys.path.append would put it on the end. But I know for certain where the people class is located at. So I'm going to go with insert so that I can put it at the beginning and look there first, make it index 0 in that list.
You get typo right there, Chris, on insert.
Thank you. So insert it at the beginning of that list and just look at the place where this is at, which on my computer would be C users, that username, documents /delete / what did I just call that? Data storage and API. Yeah, so we could add that in and tell it explicitly where to look, which obviously absolute addressing would be problematic. So that would be best. That's best if you use relative addressing. I haven't talked about that, so I wanted to mention that somewhere. Got to work in odds and ends, and I don't think we're going to get too much file writing this evening. So simple storage. I'm going to pull up my examples I was going to copy from so I don't get carried away like I just did and drift into other things almost immediately. That's why part of the reason I prepare ahead of time. I'm easily distracted and I will come up with other ideas very, very quickly along the way. Transfer data, there we go. So first off is store data.py. That was what I called it last year when I taught the class. So there's a couple of ways we can do this. First off, we need some data to work with. I'm just going to make a list here. So let's say people, I don't know, give it some sort of name, folks. That sounds like people. Make a list that would spread out a little.
I keep getting receipts and lunch, and then I will
Rather than go back to the beginning. Okay, that's indenting different than I expected, but I'm just going to go with it. So first off, we'll have a new one of the, I'm going to change this from people, import people. Usually I do the regular import one, but that would require typing people.people every single time here. Everybody seen that before? So if I change it to from people, import the people class, now I don't have to type people.people every time, we can just type people. Type in people, which is exactly the sort of distraction I made it a point to pull up this list to get away from, but we need a new person. Let's say Sally, who is 34 years old from Salem. Be one of our people. We'll have another people sort of data. This person might have been a good name because we're doing them one at a time. Maybe change that before we get too far along. It's already written quite a few times, right? So
What's already written quite a few times.
the word people,
Oh,
that's a person. So I'm gonna come over here and type person.
okay.
This needs change to person. And there's a whole bunch of places I have to dig through and change. Not so many yet. So that makes a lot more sense.
Yeah, it does.
But it'll add up quickly. And digging through the code wastes time. So usually you want to use automated features to do that. I've had it one time, there was 5 of them, and we haven't wrote hardly any lines of code into this thing we're going to be using the rest of the week. And already that word showed up 5 times that had to be changed. So that's where the refactoring buttons come in useful to change names and right click and change on it. Well, I don't know where the button is here, but if you right click on it and hit Control R, it's usually Control R or Control H is to find and replace. At least use something like that. Have the computer dig through and change all of those. Now we need some more people. Maybe.
Find is Control F.
Oh, I was doing find and replace. With the 2 boxes, so it would find all of the person, all the ones that said people, and automatically replace them. Let me go back and do that. Oh, I started typing this. The same thing on this one, Control Z, Control undo. There we go. So Control F will just find them, and then you can change them by yourself. But if you type instead of Control F, Control R, you get a find box and a replace box. So find person or find people and replace with person, which again, I can't zoom in on that. So hopefully you can see that on your screen. And then there's this all button somewhere. Used to be labeled, they changed it to an icon. This is all. Replace next occurrence, replace occurrence in section, replace all occurrences. So then it changes them all at once. Then go over to the other file. There's also a way to do it in all the files, but one file at a time works too. Still the same thing, so I can just find and replace all of those with 1 click. That's going to be available on most of your text editors. Oh, we need some more data. So Charlie, who's 28 from Charlestown. Person Corey, who's 16 from Gordon. Person Louis, with the American spelling of Louis, who's 73 from Louisville.
I'm sorry, by American, you mean right.
It works. There's different ways. Actually, we could spell it.
That was funny.
The American way would be this, right? Like the Louis is in the Disney duck. Donald Duck's nephew. Spells the English way. I guess the English people still spell it the French way. But there's lots of ways to spell it. I think I misspelled Louisville though. But that'll be fine for now. Person Jeffrey, who's 14 from Jeffersonville. That gives us a nice little data set. Oh, I forgot commas. Comma, 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 and don't need a comma on the last
Oh, yeah, because it's a list.
Yes. Any comment there? Okay, so now we have some data to work with, and technically any database just means place to store it. When we say database, we're almost always talking about relational databases. Maybe non-relational databases, but usually we specify that by saying non-relational, or NoSQL is a lot easier to say. SQL is the language we work with relational databases in. So NoSQL is a lot easier to say than non-relational.
I like NoSQL.
But any place that we can store data, that's what it means. So we have different ways to do it. First off is just a binary file. I assume everybody's seen the simple sequential text file, so let's jump right up to binary files. This is in computer readable form in order to go through the processor, right? We're writing the text file, but if we need to bring it back, it's going back to the processor, not back to the text file. So we might as well just store it in binary form, the format we need it in. There's no need for a human to read it. To do this, we'll need this. I was trying to put a label on there and be nice and organized. We'll need some, for our binary file, we need this module called pickle. Along the ways, alternative words were used at various points along the way before we settled into the terminology you're familiar with today. Some of that might change, but we use serialize as the verb that was settled into, but along the way, one of the terms was pickle. And that means prepare it to be handled in binary form. So somebody decided that pickle was a good word for that. But other words were used than the ones we know. Like at one time, yank was one of the options for what became known as copy. That's why if you use VI or Vim, or for Linux users, copy is a Y, because at one point we yank and put instead of copy and paste. So words change, but when things are named after those words, it sticks around. So we need to pickle our data in order to get it ready. Then we'll create a file. So with open data file 1 dot I need an extension for, that should be a string. I'll call it data file 1 dot I don't know, PPL for people data. The extension is arbitrary. The extension only tells the computer what software to open with. So eventually we would want to tell the computer to open .ppl with our stuff. I don't think PPL is used anywhere, is it? You might think of any? I'm sure it is. If we went and Googled it, there's probably some software that uses that. We'll open it for write WB mode. So for sequential text files, you're probably used to write, append, and read. Let's zoom in so you can see that. Write, append, and read. But we also have write binary, append binary, and read binary. So if we're going to pickle it, we want to write binary. Depending on what textbook you used in the last class, you might have seen it. The file handler is created this way. Open equal, oh, something else equals that. So file handler equals the open method. And then you start doing stuff with it. We also have this with open as, and then the name of the file handler. I often use toFile and FromFile for those names. I like this one because it fits more with that general Python syntax I keep pointing at, right? We have keyword, something unique to our situation, followed by a colon, and then we indent all the stuff that we want to do while that file's open. And it has some, not the full picture, but it has some basic error handling in there. You almost always want to override that if you're doing something really fancy where you're going to need to worry about exception handling. But it has more than just the file handler it does by its own. Does everybody know the difference between a file handler and a file? Because textbooks often say that's wrong. A file handler is the thing that can see our data. Let me draw the analogy I like. Because there's an old physical version that really helps to make it make sense. And pretty soon we're going to look at the OS module where we will actually be using, where'd the black marker go? Where we will actually be working with files. There's a lot of what, most of the time we could think of it as a file, but a file handler is not a file. A file handler is the thing that can see our file. So very old school, but have you all seen the picture, at least pictures of the old reel-to-reel tape computers? Old James Bond movies from the 60s, like Sean Connery, James Bond. There was the reel of tape, which audio tape was later based off of. It really is just 2 pieces of Scotch tape with iron filings between them. And they're segmented, so we know how far, like each segment's going to be 1 bit, but they're usually 8 bits wide, like an inch wide tape, and we split that up into 8 little segments. And then we run it past a magnet, which wouldn't look, actually 2 magnets. So I'll draw them both here. I'll do the little magnet symbol. So we have 2 magnets. One of them would be on a spring. So by magnetic polarity, because this tape is full of a bunch of iron shavings, the one on the
I've
spring
never seen that. I've never seen that.
bounce up and down. You've seen the reel-to-reel tape recorders, right?
Yeah, I thought you were putting something else, but
So this is a small thing in front of them. You would have seen it, but I'm just drawing it really big because we need to think about the parts. I'm exaggerating the parts that. So we have the two magnets. One of them's bounded on a spring, so that depending on how those iron filings are magnetized, that spring's going to bounce up and down, or attract and repel. And the other one is really stiff, so it doesn't move. So when that stuff rolls past the stiff one, the iron filings move. Their magnetic polarity changes. So this is how we would write to that. Like the magnet that doesn't move adjusts what's on the tape, and the magnet that bounces up and down responds to what's on the tape. So the read head and the write head. And then those go over to our actual processor. Back in that day would be the big vacuum tubes. Maybe starting into transistors and RAM and all that. But our data, the file itself is the tape. But the file handler is that read and write head, which actually I exaggerated there. Most of them would have 1 magnet, but we would switch how it connects. Actually, anybody that was alive in the 80s and 90s remembers those tape decks where had the record button and you always had to hit the play and record button at the same time to lock it in place. Because there was only 1 magnet and the play button activated it, but when you hit play and record, you locked it in place. That's how that would work. But that's like the file handler. It can see the data. It's not the data itself, but it's the thing that can see the data. There is a small.
so on a record player, the needle is the file handler.
That is something completely different.
Oh, okay.
I want to relate to that. I'm talking about I was talking about the computer tape, not the audio tape. But some people have probably seen the audio tape. The record player is something very, very different. So this is how computers in the 1950s.
My daughter's laughing at me over here.
I know what you're thinking of, but a record player is an analog signal. A record player is an actual model of a sound wave. So it's not a digital signal.
Yeah.
Magnet wouldn't be enough. But the old like 1950s computers, you've seen those, right? 60s, showed up a lot in movies. But they'd use tape, which is the same thing as the audio tape. Audio tape was based off of it. It's like, hey, we can't store audio. We can put lots of it here. But there is that distinction between the file handler and the file. Because the files, our operations on files are copy, right? Copy and paste that file, delete that file. We do it to the whole file at once. But our operations on file handlers are read and write data. We can see the data and know what's being changed there. There's a slight distinction, but as programmers, you will need at times to make that distinction. One of those times being a homework assignment in this class. So make sure you know when to use a file handler and when to use a file, when to work with the file itself, which that comes from the OS module. So like os.copy tree, OS is dir to check if something's a folder. OS.is file to the condition to see if something is a file versus a folder. So this is a file handler. It can see the thing, and then we just kind of put our data there. Do I have anything else fancy in the example? Nope. Then we call that pickle library. So pickle.dump, and we'll dump our people data. So we'll dump this entire Python list, the way it's stored in binary on RAM when our program is running. We'll just dump that entire thing into a file. And then when we read it back, well, we know we need it in the binary representation of a Python list. So we just store it that way. A human does not need to read that. Pickle.dump people, and then use this handler to dump it. Oh, folks, that's what I called it. I got rid of the name people. That's why. So all of our data set, we'll just dump it all at once and store it the same way it looks on RAM when we're running the program over in storage on the hard drive. And then next time we run the program, we just bring it back in. It's already in the format we need, as opposed to a human readable text file, because there's no need for a human to read that. To get it back in, create a file handler with the open method. Going to open the same file, data file 1.ppl. Only this time we want to RB mode for read binary. So if you saw something different in your previously, it is still the same open method. We're just putting it in a different place if you haven't seen that keyword before. As from file. Where's that not in there? Oh. And then we need a place to put it. So I'm gonna say I'll put it someplace different. Stuff is going to be pickle.load. So pickle.dump to send it to the file, and pickle.load to bring it back to from the file. And with dump, when we dump it, we have to say what data we're dumping. But when we bring it back, we just need to say what file it's coming from. So what data are we dumping? Where are we dumping it at? And then when we load it back up, all we need to know is where we're loading it from. And then I can like say print stuff index 3. So when I run this, let me clear this. Control L, and now hit run. From people import person. Be careful with the replace all button, because you might have something else that has the same word while it's being replaced. So what happened there. I replaced one too many people's. So notice that the only thing printed is down here, what we read back from the file, which is Lewis. And if we look over here, 0, 1, 2, 3, it looks, or Louis, looks like Louis is the third index and thing. So we just stored it in the same form it's in RAM. It's a great way to store it because we know the only thing that actually needs it's the software. So that's the one of our basic types of storage. What's next? Next I have SQLite, which will take a minute to get through. That'll take a minute, and let's just look at a couple ones real quick. CSV. I'll do the CSV one. Which I had this transfer. Let me look at the example. How can I get through that in 10 minutes that I had in the SQLite? Oh yeah, I didn't do much, just enough to show that it uses SQL. So, and then the other ones I have is listed in the exam preparation work was called transfer. So I want to do CSV there. So I'm gonna look this up real quick. SQLite. It's built into every installation of Python and other things. Everything Google does, it kind of, they require them to include SQLite. So C language, that's fine, but small, fast, self-contained, high reliability, fully featured SQL database built for programmers, basically. So everything we want from a database. Sounds good. We have lots of those. But it's libraries. We import it into our code, and then it's not a big company-wide database. It's a database for our piece of software. So we get all those advantages of relational databases, which I can sketch a few of those out when we start talking about it. We get all those right in our code. And then this other stuff, it's stable, cross-platform, backward compatible, and not only is it backward compatible, the developers who work and maintain on it have signed a pledge that it will remain that way through 2050. And that's not when it's going to end. That's the next time they evaluate it. So it's going to be working for a while. So it's something reliable, self-contained, fast, a relational database for our software. So we get all of those advantages of relational databases. Everybody know the difference between relational databases when we want to use when we would want to use SQL and NoSQL databases. I'll do this in the with a picture on the board. Because if you had that class, they probably bombarded you with technical terms and spending forever learning more about normalization because they want to do that at the introduction level for some reason. And I was like that. There's other basic usage things that everybody could use. And then the people specifically studying data analytics can learn normalization later. I don't need to confuse new people. And people lose sight of the advantages of it. So the advantages is it's for structured data. So we have structured and unstructured data. SQL relational databases are for structured data. We set it up in a table, rows and columns. Each cell is called, we got a couple colors. So one cell in the table is called a field, and related fields form records. related fields form records. I'm gonna do this, Mark. Related records form tables. And tables is plural, so we'll have another table over here with different data in it. But there will be a similar field. So tables, I'll do this in red. Tables are related by common fields. There's the whole picture that you probably got lost in when you took a whole semester with all the fancy terms and stuff.
But there's not necessarily a relation with NoSQL. There's not necessarily a relation between the tables, right?
There is, yes, there is. There's
Oh,
still a
there
lot.
is.
I will show some NoSQL stuff here at some point, not tonight.
Okay.
Because we're just gonna look at the SQLite database and the SQL. I'll quickly talk about the difference. We have all these relationships, and the thing is, then we can use those relationships. And I don't have enough colors. I wonder if one of these pink ones works. I'll just use black. So maybe we know this data point. We know from the user input or something, we know this data point. Maybe it's somebody's age. Go through those records, and then this is the town they went to high school in. So we could go from their age is related to the town they went to high school in.
Has to be because it's on the same line.
Town they went to high school in is redundantly shows up in another table, but that forms a relationship to another table. We can get from this data point over to this field, which is related to this thing, and then we could get all the way over to this data point by following relationships. We don't need all of our data. So flat files where we just wrote here, file it, sequential files, most of the things we're going to look at. If we need something from that data, that file where we're storing stuff, we need to bring that whole file, which is basically our entire database, flat file database, back into RAM to look through it. But with relational databases, all we need is the relationships. We don't need the tables. We need our starting point, the relationships, and then it'll spit out the ending point without knowing anything else other than the relationships. But basically it follows that around instead of read every single cell on every table there. So that's why it's fast. We don't need our data. We only need the connections between the data. That's for structured data. For NoSQL databases, we still need relationships and connections, but structured data for SQL databases, a good way to think about that is that's what we get when we fill out a form, like a form on a web page. Everybody fills out that same form, right? So we have the same data from every single person, which means every one of these cells should be filled. But unstructured data is what we get from, and notice I've been trying to intentionally change that word. It's a Latin word, so it should be data. Data was a character on Star Trek, but popular enough character that if you use that in America, anybody's gonna know what you say. So I have been intentionally trying to say those back and forth. It's a Latin word, so we should be using the Latin word. And interestingly, we use it in the same way the Romans did. So it's not a new concept to humanity. We just do it electronically now. But the data that we get from Facebook, we're not going to fill up a very nice table, right? Because we know one person's favorite book, where somebody else went to Applebee's last week Somebody else drives a Mustang. Somebody else has a size 11 shoe. Somebody else dated a certain person several months ago. Right? We know different data about everybody. Our table would have more empty spots than full spots. So we can't follow these sort of relationships around. We still have relationships, but we have to define them individually. We have to figure out we have to define them individually. We can't have that overall relationship. So that's a NoSQL one. We could, and then we follow relationships around, so we could get from what I just said, for targeted advertising, we could get from somebody's shoe size to who they dated a couple months ago, to somebody's best friend, to a high school mascot, to somebody drives a Mustang and know to show a certain advertisement to that person based off that.
And if there's a connection with even one of those tables, the table can't be dropped, right?
Yeah,
It can be. Then they just lose the connection. They just lose that connection. So a single connection that may have started all the little sequence of webbing could make it all go away. Okay.
because we're programmers. We tell a machine what to do. A machine knows how to run the instruction drop table. And if we tell a machine drop table, it's going to run that instruction. So a database manager would probably put lots and lots and lots of layers of protection in to prevent people from being able to pass in that instruction. But if we can get that instruction to the machine, it's going to run it. And it will destroy that entire structure in both relational and non-relational, because we still have to have relationships in non-relational data. Otherwise, we don't have any connections between them. And we might as well have a flat file that we have to read through the whole thing every time. It's the relationships are what make it quick. But back to SQLite.
Did you relational and non-relational, or structural and non-structural?
Relational databases are for structured data, which is like what we would get from a form.
Mhm.
And non-relational databases, NoSQL databases are for unstructured data,
Okay.
unstructured data, which is like what we would get from social media. And everybody fills out the same form, so our table should have every cell filled out. But on social media, there's no telling what people are going to put on there. And everybody puts something different, so we have different data points about them, but we can still find uses of it. I will try to show the NoSQL one I like. I like to use OrientDB. It's a very powerful, fast one. There's a large company that uses it to deliver 400,000 targeted ads per second. That's the average round the clock. So basically, it's really, really fast. That's massive data sets. They have huge data sets, and every second they're expecting that they need to dig through that data and figure out what specific advertisement to show every 400,000 different people.
Did you say MariaDB?
OrientDB.
OrientDB. Okay.
That's what I like. But in Python, that will be just in the odds and ends section at the end. I tried a whole bunch of them out. And the reason I chose that is because that will most closely match what people learn in the DBMS 110 class here. So basic SQL. They put effort into making it look like SQL, even though we call it NoSQL. I mean, that's what database people know, so might as well type something similar. They put a lot of effort into it, and that will most closely match what people learn in the DBMS 110 class. I'd like to a whole bunch of
Apex Oracle.
That'll be an odds and ends at the end of the semester, so you can see that, because you're probably going to want to do that. And I keep trying to tell the curriculum committee that. That's what I say every time. And move forward. I didn't get a progress. I did get. There's going to be a NoSQL database class added, but not focus on NoSQL in 110 yet. I'll just keep bringing that up at meetings until it is there. But there is going to be a whole NoSQL class. It's just not going to be required. So let's look at SQLite for SQLite. And this example is going to go pretty quick. I didn't do much here because not everybody has seen that. So the module import SQLite 3, which I'm going to redo as SQL to make the typing a little easier. Everybody seen the rename on the import? Make that a little bit easier. And to create it, we do DB. That's going to be the variable name. I'm just going to call it DB, make the typing nice and easy. Is SQL.connect. So we form a connection to our database, which is stored as a local file. Oh yeah, we still have to go back and look at the files. Documents, delete. That is storage. So notice it created that PPL file for us. Doesn't know what it is. It's a binary file. If you open that with, say, Notepad or Text Strangler, if you're on a Mac, the most basic text editor, you would just see a bunch of binary stuff there. It would try to turn some of it in there, but it's mostly binary. So this will be data file 2 dot. Usually it's DB. That was in the example. Yeah. Typically, SQLite stuff is done as .db. And I'm going to use that same name for the variable. So the computers kind of know what they are. Let's do a create query. How many of y'all have seen SQL? Has everybody seen SQL? I see head nods here. If you haven't seen it, this is going to look really, really confusing. We're getting ready to write something in another programming language. Let's say create table. If not exist, we don't want to recreate it every time, or we don't want a bunch of redundancies. But if there's not a table to create that exists, create a table. I'll call it people. Whoops. People, let me add some more space here. And people needs a name, age, and town fields, which could be a little bit better. I guess we need an ID as well. Let me go retype that. I was going to type it in segments, but I'll just do it. So
Yeah, 'cause the ID would be your primary key, right?
an ID, which is an integer, primary key, auto increment, which in SQLite is one word. A lot of people don't realize SQL is a category of languages. There's a bunch of different ones. One of the first things I look at to try to figure out which one I'm looking at, if I don't already know, is the word auto increment, because that's going to be spelled different. Sometimes it's one word, sometimes it's two separate words, sometimes it has an underscore, and you can narrow down what version of SQL. SQL is a entire category of language. That's like saying open type language. Like, Python is definitely not our only open type one. So it might look a little bit different than the SQL you're familiar with, but you would definitely know what integer, primary key, and auto incrementer mean, right? No matter what SQL you saw. Some of them might have been abbreviated. Name is going to be text or varchar if they drilled that into your head, but text will give you up to 255 characters. And until you get into optimization, you don't need varchar. We spend way too much time on optimization and normalization in that class. And it confuses people, and they miss the important parts that they actually need from it. I have made relational databases that are entirely blobs. That's binary large object. So what we did up here, just send the binary form we have in RAM there. That's what goes into a blob, which is, I think, up to 24 megabytes of binary code. If that's not enough, then you go to a medium blob and a large blob and a very large blob. I've made databases where the type is always blob. So this is like binary code. That is as far from optimization as you can get, and it worked fine. So sometimes there's way too much stuff spent on that and things get lost in the detail. Age is an integer and town is text. Oops, what did I just push?
So you're saying we have to type out integer for SQLite?
That's one of the ways to do it.
You can't use int? I just want to mentally,
I always type out integer, but
okay.
probably works. I use integer and real are the two I use because I don't dig into the optimization. This isn't going to be a massive company-wide database that's going to grow. This is for our software, our own software.
What is real?
Floating point, real number.
Oh, okay.
So notice we just put a SQL query to that variable, which obviously we could type that in the method we're getting ready to call, but it's a lot easier to pass in the variable and maybe spread that out over several lines. Right? S starts as a blank string, S plus equals hello, S plus equals world, and do the string building. That's a better form overall. I wanted to type it in one line because that's what y'all would recognize as SQL. If we do the string building over multiple lines and there's an error, we can jump right to the line where the line is. We don't have to dig through that whole long sentence. So this is a better form, but I wanted to make sure and do it so you all kind of recognize that SQL statement. And then I can say db.execute query. Execute create query. When I write this now, so for P in people, before we test this, just to because it's coming on time to wrap up. I at least want to get through this. There's only all I was going to do is write data to it and read the data back. Insert query, which y'all probably remember these, right? They're kind of a mess. Insert into our people table. So that's a table, so I'm going to make that capitalized. And I'm not going to insert the ID, that's auto increment. So I need to specify what fields we're going to. Name, age, town, and then the values and which values we want to pass in there. Everybody remember that? Those who have had SQL in a class remember getting very, very frustrated about the insert queries. Since there'll be variables and stuff, I would always recommend typing the thing first, but I'm gonna not type it to, I'll type it in the way it needs to go, but I would always recommend typing an example out first with like specific things, right? 22 Clarksville, and then come back and put in the variable names afterwards, just to keep it straight. I'm just going to type it in there. So I'm going to end that string. So the values are p.name, because remember we made a data class specifically to match this table. It's already the data class and the database match. The data class is for RAM, the database is for storage. See how they go together and why we use the same terminology and stuff. So we have a class right for it. So p.name. Oh, that's a string. So I need to escape out and put quote marks before that. So plus back into a string. And name is text. So whoops, that needs surrounded with quote marks. That's why I recommend doing the thing first. And then a comma. And then age. Oh, luckily that's just a number. So we can just break out of our string and do P
Oh,
dot,
you're taking me back to 253 right here. I'm starting to twitch.
and a comma. Yeah, you remember doing a lot of this in the PHP, right?
Oh my gosh, yeah.
This is what we did all like day after day after day is that. See how it shows up everywhere in all the programming classes? When was that? Was that 2 years ago? I think I said it back then. It's like, don't worry, you will see it again.
Yes.
I'm guessing
Yeah.
it should be about the 4th or 5th time you've seen it now. So hopefully it looks better than when we have that PHP class.
It makes a little more sense, yeah.
And then we need town, but that's a string. So to pass it into the query, we have to do the opening quote mark, which is Python. So we could do a nested single quote mark. I would always recommend against that. Just do escape sequences. It's only one more key press, and digging through nested, trying to find
It's easier to see it.
mess.
It's easier to see it than the single.
Yes, yes, and that's exactly what it is. Remember, you're gonna have to debug this stuff at some point. So escape sequences are easier to see, and yeah, remember you have to debug it. So P dot town plus that closing quote mark, then that, and a semicolon for the thing. There's only one instruction here, so I left it off the first time. If I come up here, I really should have put a semicolon at the end of that string. Wait, what half that string disappeared? Name, age, town, parentheses, then semicolon for the in, because SQL requires semicolons. That gets extra confusing when we do it in C family of language or a family that uses a language that uses semicolons, because then we need the semicolon for the SQL and the semicolon for the language we're writing the SQL in.
End of statement.
Yes. Yeah, all of that stuff, then end of instruction, end of statement, end of claim. So now I want to run that. So make something called cursor to grab the return of it. So those who have had database class, you remember when we put in a SQL database, we run an insert query, what do we get back? We get back SQL will return 1 for rows affected. If we run 50 insert queries, we get back SQL will return 50. If it crashes, we get back -1. 0 is success because we can insert 0 rows of data, especially when we have clauses like if not exist. Right? We don't need to insert it again. We just need to make sure it's there. But so 0 is valid, but negative means something went wrong. So we need to check what we get back from the database, which is going to be an integer, and it's either -1 or something positive. -1 means a failure. 0 and positive numbers are the number of rows affected, which those who aren't utterly confused by the last couple lines I typed, you know what that message looks like. MySQL will return number of rows affected. I'm sure you've seen it a time or two. We want to execute insert query. And then we can check that. I don't know why it's not staying indented. Oh, actually, I bet I do. That's why. Yeah, so we're over here. So now if cursor, which is the return from running that query, so it's going to have a lot of stuff in it. One of them is row count. Row count is greater than or equal to 0. That means no error. Print added the data. Otherwise, print there was an error. That way we know what happened. Oh, wait. It's not people, it's folks. I gave it the wrong name. So does that make sense for those who have seen SQL before? For those who haven't seen SQL before, that's probably really confusing because we just use Python to run instructions from a different programming language. Then we can grab that data. So I'll say a select query equals, don't know what a select looks like, right? Select it's name, age, and town. Name, age, town, because we didn't put an ID into our own field. I guess we could have left the ID out of there. But our data class, I forgot to put an ID in. So there should probably be an ID here to line up with the ID in the database. But it'll be okay. I'll just ignore that in the select query. Just make sure you don't do a select all. Unless you have all of the fields there. Select those fields from
It
people.
would only matter though, right, if we had a required?
Yeah, that would work. Actually, we haven't run it yet. I could take the ID out. We only have one table. We don't need to worry about the primary keys. We're just storing our data, right? So now I can probably just run a select all. I just remove make sure your data class lines up with that. For good form, I think everybody that knows about databases knows it would have been better to add an ID to the data ID field to the data class than remove the ID from the database, but they line up now. If you haven't seen this before, where one, that's one is in zeros, false, one's true. So all conditions are true. So that's like the making a loop that says while true. The condition is always met no matter what field we're looking at. Then we say cursor. Okay, thought there might have been an indent error there. Is db.execute. Select query. And for row in cursor. So a cursor looks at the row one at a time. Cursor's kind of, actually, if I hadn't erased that earlier picture, a cursor is a lot like the read head. It's the thing looking at this row of data. Then it looks at this row of data, then it looks at this row of data. So for each row in the cursor, which hopefully reminds you of for line and file. Hopefully you've seen that by this point. Let's print row. Print row. I'll do that. And then we'll make some other changes. And when we're done, db.close. I always want to sever our connection to the database at the end. Even though it's local to this software and not just something on the internet, still want to be careful of things like SQL injection. Oh, when we run this, got some typos. Nobody said anything. Name and town are fine. We can keep, those are strings. But you all have seen this problem many, many times, right? Age is not a string. Oops. So we need to turn that into a string so we can concatenate it.
Mm.
And now we need to go over and make sure we didn't start writing files. Data file 2 is database file. So it tried to start doing stuff. I'm going to delete that. We never hit the line to close that file. So that's going to be a problem. I'll just oh, no, this will work. I think if I restart the kernel, that'll release the lock on it. Okay, so want to delete that. So I had to restart the IDE.
How can you tell it was released?
So the Python interpreter was what was using that file.
Mm-hmm.
So I closed the interpreter, which is basically like I restarted the IDE.
Okay.
Brought the IDE to an end and started
Cut this-
the IDE.
Cut ties.
I left open file. Because we never got to
When you were
that.
just looking at your file, when you were just looking at the file manager, how could you tell that it was severed?
Oh, from here I couldn't. When I hit delete the first time, it said the file is in use.
Oh, okay, okay.
Needed to do, but there was nothing, nothing here. It's, you're probably thinking of like an Access database where you'll see the little padlock icon on the Microsoft Office stuff. They spend a lot of time adding that. As software developers, you would need to add that to the file in order to do it.
Oh, you had a pop-up window that was saying try again or cancel. That's where you seen that it was in use?
Yes. It's a,
Oh,
it's a,
okay.
the files in use.
Oh, okay, that's where it was. Okay,
I've just seen that error message enough times that I knew what it was.
okay.
So notice down here, well, there's the earlier part. No error messages this time. Added the data, added the data, added the data. We didn't get any error messages. And then we got a bunch of tuples. We didn't talk about those in class. The immutable ones, they're lists, they can't be changed. It's like, oh, this is the special data stored over in storage. It's just explicitly what this is. We're not going to change it here, but it comes back as a tuple, but we can still refer to any points in there. Let's filter that. What do we have? Ages 34, 18, 16, 73, 14. Let's check for adults. So select name, age, and town from people where age is greater than 18. Greater than or equal to 18. We've seen all that, right? Then name, age, town, it's a tuple 0, 1, 2. I only want the names. So I can filter it in both places. Can filter it in the SQL, or we can filter it when we get back. Either one works. Definitely something you're going to play around with, but we get all the advantages of the database. So we get all the ages of people over 18. Notice it added the data twice. Because it gave us that message, added the data, added the data, added the data, added the data. So there probably should have been a check to make sure the data didn't already exist before we added it more.
How many people were on that list again? Because I thought only one was under, no, you had a 16 and 14-year-old. Never mind.
Yeah, I know I was going to filter that, so I made sure to put at least 2. Okay, notice the computer did recognize that icon. I make those large, extra large. The computer knew what to do with the database icon, but not that one we made up. That's too big. Large. There we go. If I double click on it, open this DB system file. Notice it doesn't just say file. These are used by Windows and other programs. Editing them and modifying them could impact your operating system. So that's something you probably, this is a standard example for exception handling, right? Users messing with the files that you create. But if you do a SQLite database, it comes with a message to tell the user, don't delete this, don't edit this. This is an important file. It's right, that's built into the SQLite database. You've probably seen that message before and not know where it came from. So a really, really wonderful thing for programmers to have. It's built in everything in Python. We get all the advantages of a relational database, and we use SQL, and there is light. So it's stripped down from the SQL you probably studied in the DBMS 110 class. But SQL are all a little bit different. Okay, I didn't get nearly as far as I wanted to tonight and still took longer because I was hoping to look at XML, JSON, and CSV. Those are standards great for transferring things, right? Since I buy a CSV file, it opens up in Excel. Or the biggest thing is CSV is just Unicode values with Unicode commas in between them. That is by far our smallest data file size. When we look at it, like we'll see, we aren't going to have big examples, but we'll still see on the like XML and JSON, you know, like 80 kilobytes, 120 kilobytes, and then the CSV file will be like 6 bytes. It's just pure Unicode with commas in between them, which is still pure Unicode. Very, very, very small files, which are great for transferring, especially large data sets. We have large data sets, we want the smallest file size possible to get across that internet. So that's why that one's a standard. The other ones, they have uses, we'll see those on Wednesday and then get started talking about the API stuff. The API will actually go really, really quick. We're just looking at the first step of the API. And there's a bunch of stuff. Does anybody have any questions about it? So started talking about data classes, objects, and into some storing them so that on Wednesday, when you get to the homework, you can actually transfer them. One of the videos has SQLite for the data, and the other one just puts a list right in the Python code and uses that for the data. I'm going to ask that when you do the homework for the APIs, you do use one of the things we see on tonight or Wednesday night. You're going to transfer JSON, so you're probably just going to use the store it as a JSON flat file. Then you read it from the file, send it across the internet, and retrieve it. Something else will retrieve it in the same format. That'll be the easiest way, but use one of the forms we see this week. Okay, that was about 5 seconds. I assume that means nobody had any questions. If you have any, let me know. Otherwise, you all have a great evening. Looks like we got about 30 minutes left for class time. I'll see y'all on Wednesdays, and we'll do the formats for transferring. They're just libraries. So like import JSON, and then there's a method built. Import XML, there's a method built. And then we'll jump into APIs, which will connect to the internet. I'll see you on Wednesday. Have a good one.
Hey, Chris, when's that labs function, classes function extension due date?
As soon as you can get it to me.
Okay, all right, good night, thank you.
Yeah, I just didn't want to make it due before we talk about it in class. We've talked about it in class now, so as soon as you can get it to me, because we have other stuff going, we'll have other stuff built off of it. That's an important thing for everything we do going forward, so.
Thank you.
Do you mind if I pick your brain about it real quick?
No problem. Let me stop the recording real quick.
Awesome.